Welcome to your data visualization workshop brought to you by David.
Samarth.
Hello, Eliot.
Yep. So we'll all be helping you out with data visualization. So basically in this session, we'll be delving into this exciting world of data visualizations and explore the very powerful capabilities of these Python packages, such as Matplotlib and Seaborn. We'll also be taking a closer look at creating interactive dashboards using Tableau, in which basically that is what Elliot's going to do. And then basically the point of this is to basically help you get a deeper understanding of basically how to effectively communicate insights from your data through visual representations, such as like graphs and like Scatterplot and then like, heat maps and stuff. So yeah, get ready to unleash the full potential of your data viz creative skills. Yeah, but anyways, yeah. All right, so first off, we're gonna start off by downloading the most subscribed 1,000 YouTube channels dataset. This dataset is basically from Kaggle. If you guys, so in order to download this, if you guys haven't been to our last workshop, basically what we have to do is we have to install open datasets. And basically what this is that it pretty much like connects to your Kaggle account. And basically once you do that, you can then you can be able to directly download your data set from Kaggle. It just makes the process very easy. So if you guys like have like a API key from the last workshop, you can use that same API key. Otherwise, you have to just go to the Kaggle website, register with your Google account, scroll to your profile, and then just basically like scroll down, and you can be able to see your key. And then yeah, I can show it to you guys right now if you guys want me to. So Kaggle. Yeah, go to your profile, go to accounts, settings. You go down and you see here, this is basically where you can find it. Or you can create your new API token key. You can also expire your old one if you want to, but if you guys already have one, then you should be fine. So yeah, I am going to download the data set. So this right here is the link to the actual data set. So if you just like basically run this chunk, and once you do, you just have to provide your username. In this case, my username is David Ryan 7. And then the Kaggle key, you can just get it from here. And yeah, once you do that, you should be able to have it downloaded. So it should show up over here. Yep, it looks like it's showed up. Good. Yeah, does everyone have the dataset downloaded under Google Colab? Give me a thumbs up. Okay. Cool. All right. Yeah, so let's first take a look at the YouTube channel dataset. So we'll first have to import our NumPy and pandas libraries. And once we do that, we should be able to read in the dataset. And right over here, you can basically see like what the dataset looks like. You have your rank, which is pretty much like how the YouTube channels are ranked from like first to 1,000. You have your YouTube channel names. So you got like Mr. Beast right there. If you guys are fans of Mr. Beast. You also got strangely YouTube movies, which has the second most ranked subscribers. Pretty insane. But yeah, you get your subscriber counts for each of those YouTube channels. You have your video views, you have your video counts, you have the category for which that YouTube channel belongs to. So for example, like T-Series, he's like a music YouTuber. Mr. Beast, he's an entertainment YouTuber. And then yeah, you can also see here like what year they started in. So before we want to do some data visualizations, we want to also take a quick look at the types that each of these features in a data set contain. So you can see here that the rank and like the started year is an integer. Now, before I move on, I just want to ask, what is exactly wrong with this data set? You go ahead. Good point. So yeah, that's basically the main problem. Pretty much subscribers, video views, and video counts are basically objects. In other words, they're pretty much strings. You obviously don't want that for when you go on to make visualizations. So you would definitely want to clean this data set by converting these strings to integers. So in order to do that, we're gonna have to clean our data set. So I think you guys have a pretty good idea of how to convert a convert like a feature from a string to an integer. So how about you guys do this quick exercise? I want you guys to convert the video views, the video count, and the subscribers columns, which are all object data types, all into like integer 64 types. Does that sound good? All right, I'll give you guys 5 minutes to do it. And then yeah. Okay. All right, well, if you guys have any trouble, I decided to just type it in the exact code you guys need. So basically, if you guys need a review, pretty much string dot replace. Over here, what it does is that it takes these numbers here that have the commas at the bottom, and basically it like converts into just a full number without the commas. And once you do that, you should be able to easily convert them from like a string to an integer. So yeah, let's just run this, and then let's get a preview of the data set, and then yeah, that looks good. So yeah, do you guys have any questions, or do you guys need more time? We're good? Okay. All right, so yeah, so let's now get started with our first visualization library. So we're gonna start out with Matplotlib. Matplotlib is a plotting library for Python. It pretty much like provides a convenient way to visualize and analyze data. It is most widely used data visualization library in Python ecosystem. And it also provides a wide range of like customization options to meet all different types of plotting needs. So if you guys like want a really customized scatter plot or like really customized like linear regression plot, Matplotlib is great for that. It's basically like the granddaddy of like all visualizations. So yeah, it pretty much like integrates well with all the other popular like Python libraries, such as like NumPy, Pandas, and as well as Seaborn, which we're going to use later today. So if you guys want like an extensive comprehensive guide to this library, you can click on the documentation here. It pretty much like gives you all the information on how to do each plot and stuff, and it's really good. So whether if you're like a beginner or experienced data scientist, Matplotlib is definitely a must-have tool needed to create some really good data visualizations in Python. So to get started, we'll need to make sure to import matplotlib.pyplot. Pyplot is basically a sub-library of Matplotlib, which helps you like plot all of these visualizations. So with pyplot, you can do like a wide range of like plots, such as like line plots, scatter plots, bar plots, histograms, and much more. It also like provides a high level of customization, allowing you to customize your plots with labels, titles, legends, and other like annotations. It also has like a bunch of like functions for you to use in order to control the style of the plot, such as like setting the color and like size of the markers, also like the size of the graph as well. So yeah, we're gonna get started by creating our first scatter plot. So the scatter function like generates a scatter plot. The two parameters that you need to put into the scatter function are arrays or lists of the data for the x and y axis respectively. So the scatter function takes this data and it creates a scatter plot, which each point represented as a marker on the graph. So we'll be creating a scatter plot for the YouTube dataset with the subscribers as the x-axis and video views as the y-axis. So you can also add a title, an x-axis label, and a y-axis label as well. So you can see here, plt.figure, what it does is that it basically adjusts the size of the graph so that it looks much larger compared to like a default one. The default one's usually like 4 to 8. But yeah, for this one, we're just going to do 8 to 8. And you can see here that we put in subscribers here as like pretty much our x-axis and video views as our y-axis. And pretty much you can see here like I also added the title function here. What the title function does is that it pretty much like lets you set the title of the graph. So for this one, it'll be like our video views per subscriber count. You can also customize the font size as well. as well as the font weight. And there's also a bunch of other parameters that you can use to also customize your plot as well. You can also set the X label and the Y label as well using the X label and Y label functions. So you can see here, this if you guys do the code above, right over here, you can get this graph generated right over here. So yeah, does anyone have any questions in regards to the scatter plot? Yeah, so let's just say we want to look at the growth of YouTube in terms of their top content creators when they start making content. So we can use the started visualization. We can use the started column to basically visualize this. And we can create a histogram plot showing the creation of growth of the YouTube's top content creators. So what we're going to do is that we're first going to basically set fig and ax to basically subplots. What it does is that figure pretty much lets you customize the size of the graph. And like ax, what it does, it basically lets you customize the graph based off like labels and such. As well, you can also like set the you can also set like which plot you want. So if you guys want a scatter plot or a his plot for that matter, you do basically all you have to do is do ax.histogram or just his for short. So you can see here, like for our first parameter, that's usually where you put the data. For this, we're just going to put the started column here. And what we're going to do is that we're going to set the bins to 20, the line width to 0.5, and the edge color to white. Now, before I move on, who knows what bins are? Oh. Rohit?
It's like grouping some of the values together, is that right?
Yeah, that's pretty much right. So basically what it does, it helps group the values together based off like a certain value. And usually like line width kind of helps you like adjust the size of it. So once you do that, yes, once you basically do that, you should be able to get this histogram right here. So what you see here, it's a pretty short histogram. Like you can see here, like the default. You can see like the default like starting point of like the graph is like 1970. And then it goes all the way up to like 2022, which is basically our time or last year's time. But yeah. Now obviously this graph is kind of like set far to the right. So we want to fix that. So how do we fix it? Well, we start by adding an axis limit. So if you guys want to do that, all you have to do is do ax.set, in which what it does that it pretty much helps you like set the limit of the axes from one point to another point. So over here, we're going to be setting the X limit to start at 2002, which is I think around the time that YouTube started. Yeah, and we're gonna go all the way up to 2022. And we're also going to set the number of like subscribers, which they're like in millions from like 0 to 300. And so once you do, you should be able to get like a much better graph where basically you can see the growth of YouTube based off the number of content creators that have like sprouted. So can anyone like just raise your hand and like explain like what's like the biggest takeaway you got from this graph just by looking at this? Nothing?
And if you guys are confused, the x-axis is the year that the channels have started, and the y-axis is the number of channels that started during that year.
Yeah. So basically the x-axis is like pretty much the year that these popular content creators started. So yeah. What can you guys like derive from this histogram?
Median would be around 2012, I guess, assumably. And it was when most of the giant content creators started to.
That's a really good point. Yeah, that's definitely so around like 2012, between 2011, 2012, like we started to see like a huge sprout of like content creators like rise up and become like one of the top. And obviously later on they became like, like probably like the greatest YouTube creators of all time. So yeah, that's a very great insight. So yeah, does anyone have like any questions as far as generating a histogram goes? No. Okay. Yeah, so let's just get going. So obviously, before we move on, I kind of want to do a quick exercise. So using kind of like the documentation from Matplotlib, as well as just using your own coding skills, I want you guys to create a pie plot, a pie chart representing the various categories on YouTube dataset. So basically, like you know how to how's like there's different categories on YouTube, such as like entertainment, music, and all of that. I want you guys to create a pie chart representing that. Also want you guys to include the labels of the categories, as well as like the percentage showing how much of the pie it takes up. Does that sound good? Okay, I'll let you guys get started. I'll give you guys up until like 5:30 to do it. If you guys want to, I can give you guys a quick look at the documentation. So if you click here, it should lead you to this, and you can like if you guys want to, you guys can go to plot types over here on matplotlib.com, and basically like what it does is that it gives you like a guide to all the different plots. So you can see like scatter, bar, stem. And if you guys want like the statistics plots, you got the histogram plot, you got the box plot, you got the violin plot, you got the you have like pretty much all these different plots over here. You can even create like this cool like tri-contour plot, which I have no idea what it is, but it looks pretty insane. And you can also make 3D plots here as well. So you can create like a 3D scatter plot. So like you can have like three different like data types that you can like, use to create like a 3D scatter plot.
3D scatter plots are really important because if you want to see a correlation between three different variables, oftentimes for industry-wide data sets, you'll have variables with like, or you'll have data sets with like 78, 79, like hundreds of different variables. And a lot of companies will task data analysts and machine learning experts to find a correlation between the types of data. So you'll have to go through this thing called feature selection, where you're looking to find the best correlation between certain features. And you have to test out every single, feature and see which features correlated will, show an interesting conclusion for the data.
Yeah.
And that's why these types of graphs are.
Yeah, that's a very good point.
So you ever take like 170 or CS 170 or CS 171? You guys will do something related to feature selection and cross-analyzing, different features depending on how they correlate with each other.
Yeah.
You want to like write the line 1
Yeah. So I guess while you guys work on it, I can like write down the solution to it. So obviously, what are the two main variables you want? You guys want fig, and you guys also want ax. So fig is important for setting the figure of the plot. So in order to do that, we'll just do plt.figure. And you guys can set the fig size to whatever you want. For me, I just like to set to 15 by 15. It's a good size because it gives you like a bigger, it gives like a bigger pie. So you can get like a more in-depth look at like the different like pieces of the pie. Kind of like that allegory. But next part, you guys also want to set the ax. So over here, this is where you can like set the axis size and all that. Or this is where you can also like add the axis too. So in order to do that, you just have to do big dots add axis, and basically what it does, it pretty much like adds the axis for your pie chart. So we're just going to set it to 0, 0, 1, and 1. And that's usually like kind of like the default. But I'm just going to put it here just to show what the default is. So yeah. Next, another thing we want to do is that we also kind of want to like bring in you want to collect the categories, like the different categories of the category column. So in order to do that, we're going to create a categories variable. And we're gonna, let's see, yeah. We're basically gonna go to the categories column and we're gonna get the unique values. So to do that, we're gonna do category YouTube df category dot unique. And what the unique function does, it pretty much like gives you all a list of all the unique values within the category, like within like the category column. And so once you were able to do that, then you can start creating your pie chart. So we're going to do x.pie. And then we're going to do YouTube df category. And then we're going to do dot value counts. Now, for anyone that's been to like the recent workshops, what does the function value counts do? Does anyone know what value counts does? No? Okay.
It counts how much each type of unique value there is.
That is correct. It basically gives you all the counts of all the unique values. So if there's like, let's say 15 like observations of like entertainment, then it'll list you out like 15, pretty much like 15 like observations of entertainment. So that's the true power of value counts.
What's the unique
Unique function?
unique value? What do you mean by like unique value?
So basically what it means is that so you know how like in each column, how it gives you like a certain observation of like this. So like you're getting like a certain number of entertainment observations and like a certain like number of music observations and like TV and so on, all of that. So that's kind of like that's usually what value counts does. Like it gives you a list of like of the unique values and how many of those observations there are.
Okay.
Yeah. But yeah, once you guys do that, you should be able to generate a pie. So yeah, you can see here, you guys can get your pie. Pretty cool. But we're missing one important thing, and that's the labels, as well as the percentage. So if you guys want to do that, if you guys want to add in the labels, all you have to do is do labels. You just have to go to the labels parameter, and you have to set the labels parameter to categories. And once you do that, you should be able to get like, the oh, it's not working. Did I spell category right? Stop by. That's weird.
Is it category, not categories? No, right?
Wait. Oh, I'm dumb. Yeah, that's right. Okay. I misspelled categories, but yeah.
That's you.
Nice. Thank you, everyone. Okay, yeah, so you can see here, like I labeled like each piece of the pie, which is pretty neat. And if you guys want to go more in depth and like see the percentages and stuff, all you do is like go to the auto percent. I'm sorry, oops, not that. The auto TCT parameter, otherwise known as auto percentage. And you just have to format it in a way in which you can display the percentages. So in this case, we can do like 1.2%, in which what does that, it pretty much like prints you the percentage with with two decimal numbers. And so yeah, we'll do that. And yeah, it should be able to work from there.
Kind of hard to see. What did you type?
Auto percentage, and I did like percentage 1.2, F for floats, and then percent. Yeah.
Thank you.
Okay. So yeah, this looks all good. Do you guys have like any questions in regards to Matplotlib? This is pretty much the end of it, but yeah. Does anyone have any other questions? Does anyone have any other questions in regards to Matplotlib? Any doubts, concerns? None? Okay. Yeah, so in that case, next part will be Seaborn and pretty much Samarth will be leading this workshop. But
Yeah.
yeah,
Well, thank you, David. Woo.
yeah,
Yeah, so I'm gonna be just going over some Seaborn functions. Seaborn is a Python visualization library that's based on Matplotlib, and it's really great because you can draw really informative and really attractive graphs, which is, really important because the people that look at your graphs are most likely customers, clients, people that don't know a lot of data science, but will see pretty colors and will see upward trends and be like, oh, this is important for my business. So Seaborn is a really great tool that we can put in our statistics arsenal. So Seaborn offers, the following functionalities. It's really good for high-level abstractions. They have a lot of distributions, a lot of random distributions, all this stuff. We're going to go over a few basic graphs. I'm just going to show you, generally how you would load up a data set within Seaborn and then use different graphs. If you want to look more about or more into Seaborn and the documentation, PyData has a really, really good comprehensive list of all the functions in Seaborn, all the, graphs you can do. It's a really great resource and it makes everything really digestible, gives examples. All right, but let's start. In order to use Seaborn, we can import Seaborn as shown here, where
we
you
already
just
imported it. though.
import Seaborn as SNS. We've already gone over NumPy's Panda, Matplotlib, and then we're reading in the CSV file, and then we just print out the head, and then we did the data cleaning earlier today. So we do that. Okay, so first thing we're gonna do with Seaborn is we're gonna first create a plot that shows the categories of the top channels, right? So what is the number one's channel category? What is number two? And we'll look at a trend between those. So Seaborn has a built-in theme that allows you to change your graphs and make it more aesthetically pleasing, in my opinion. So the first thing we'll use is a plot called real plot or REL plot, which shows a relationship between two different variables and the mappings of other variables. Mapping means the different categories for this example that we're going to show. So the data refers to, of course, our data structure, which is our CSV file that we're reading, right? So we have SNS for the first thing here is SNS.setTheme, which sets theme as Seaborn's default theme, and then as opposed to like the Matplotlib plots that we've seen earlier. And then within our real plot, all we have to add is the data, which is our data set. And here I'm doing 50 values because the more values that you have, the harder it is to see. So I'm just going over the top 50 channels. And then we're setting our X as our rank, which is, the however many subscribers they have, Y subscribers. It's a bit redundant to have X and Y as both subscribers, but this is just to show, how many subscribers these categories have. And we'll show our hue as category, and hue being, whatever color each category represents. Yeah. So if we run this in our thing, there's an error because SN is not defined. I have to run
Oh,
this file and
it should be fine. Should be fine.
no, I have to copy this right here. Command, right?
Fancy.
So I'm just gonna add the CSV file here. And then now when I run this, we'll get the same thing we had earlier. And then we clean the data in the same way earlier. And then now when we run this, we get this very attractive graph that shows the subscribers here for the top 50 channels, and it shows a rank here, right? So there's some really interesting things to note within the graph. It's hard to see on the projector, but if you can see here, each of the colors correlate to the different categories, right? So we can see that the top channel is music, followed by film and animation, then education, shows. And if we go through the data, we can see that, T-Series is a music channel, top one. And then we have YouTube movies, which is film and animation. Then we have Cocomelon, which is education, so on and so forth, right? And what's interesting to note about this data is, there's a line, right? Because of course we're correlating subscribers and rank, so there's obviously a correlation. And we can also see that there's a huge jump between the first the top channel and then the second most subscribed channel. So what do you guys have any ideas on if there's any better way to show this graph? Is there any graph that you think would be really great to interpret this data with?
I think 3D graph might work because since it's having three variables.
Yeah, it's
So-
true. A 3D graph would work in this instance if you want to show that category, right? But let's just say with two variables, right? Let's just say with subscribers and rank. How is the trend of this graph? What does the trend of this graph show?
High subscribers tend to have a higher rank.
Yeah, I mean, in general, yeah. And that's basically assumed within the data, right? So you're exactly right. We can see that there's a like almost looks like a line, right? Like an exponential graph or like that graph that shows as the rank goes down, the subscriber count gets more pressed in, right? And there's more variation at the top, but there's like a clear trend. So what we can do is we can create a line plot that shows the exact same thing. So using real plot again, we can have the data be the same, but instead of adding our hue, we can use the kind keyword here, which essentially says, hey, I want this real plot to be either a line graph or a scatter plot. And we'll show a scatter plot graph later on, but this keyword essentially specifies if you want to use a line graph or a scatter plot. So you either specify here that it's a line or a scatter. And then when you run this, boom, we get a line. And here I'm not doing just any 50, I'm doing all 1,000. So you can see there's a clear trend between as rank goes up, or as rank gets to the top, number one, the subscriber count increases almost exponentially. But as you go down, you can see there's a lot more average YouTube channels with the same amount of subscribers, as opposed to like the top 1% of YouTube. So let me know if I'm going too fast. I'm just gonna breeze through a couple of these data distributions. And most of this is all for just for your own personal projects. If you want to go to Kaggle, pick up your own data set, and then use these kind of graphs to show any correlation, causation between different variables and come up with interesting conclusions for data. So we can see there's a line graph and then it's exponentially decreasing as we go down. And this can say a lot depending on which customer, which client you're talking about. Oh, you have a question?
No.
So this can say a lot depending on which client or customer you're talking about. But let's say we want to focus at the top 10 channels, right? Let's say a customer is in your top 10 and they want to say, hey, I want to look at my competition and see what are they doing, how are their stats, and assuming YouTube allows this, let's see what they can do, right? So let's say we graph the line plot of the first 10 channels. We're specifying here that within the data, we're only looking at the first 10, which is why it says head, and then we're specifying the number 10. And then when we run this, we can see that there is a clear difference as we go down the line, right? So you can see between number 1 and number 2, there's a huge drop of, I would say 80 million subscribers from the second most or the first most subscribed channel and the second most subscribed channel. And then you can see second to third is not that steep comparatively. And then third to fourth, there's very little change, but you can see fourth to fifth, sixth, it goes down. So it's a very interesting thing to note for YouTube. And you can come up with a lot of conclusions for that. For example, you can say, hey, T-Series, has a huge fan base in India. And because of that, there's a lot of ad campaigns. Everybody in India gets the same music from them. So it's obvious why they're number 1. Number 2, same thing. It's YouTube movies. They have their own, everybody that uses the platform will likely subscribe to it for one point or the other. And then we can see Cocomelon, educational, et cetera, et cetera. So a lot of interesting trends that you can conclude using this data. Let's say we want to use both hue to find the to show the category, and we also want to show a scatter plot, right? And this time, instead of going through subscriber counts, we'll look at video views, right? Because we typically associate a higher amount of subscribers with a higher amount of video views. So let's see if that trend actually exists and is universal within this data set. And let's look at the top 100 channels instead. So when we run this, we see that, oh, wow, not all YouTube channels that have the most amount of subscribers have the most amount of views. We can see with the rank still being the x-axis, some channels like here have more views than like this channel is number 4 in the amount of views, but it is like number 20 in the most subscribed. So it's really interesting to note how some channels, even though they have a huge dedicated fan base, a lot of subscribers, they might not be pulling in a lot of views. And that's really important, let's say, for YouTube's monetization model, which will prioritize views. And typically channels will associate that with having a loyal fan base, which comes from subscribers. But as you can see, there may be channels that have specific videos that have more mass appeal. So even though people aren't subscribed, it'll keep appearing on the front of trending and et cetera, all that stuff. So there's very interesting conclusion that you can come up using this kind of data. Yeah, so one thing to note is the number of subscribers with the number of overall views. It's a little bit messy to interpret with this graph, so we can just add a couple of labels to it. And we'll come up with this graph. Now we can see that it shows the YouTube channels by subscriber at the bottom and the number of overall views that the channel has when we're setting up the x-axis and the y-axis. And one interesting thing I wanted to highlight here was this plot line. And what this does is essentially says, let's say you want to show a trend line within your data. Let's say you want to show, for this many views, this channel has all this stuff. We can create a dashed line by adding this dashes keyword, but you can also change the color. And I've set this y-axis to a specific number. And this number is probably outdated and et cetera, but does anybody have an idea what this number represents? It might be a completely random number to you guys, but anybody have an idea? That's a good idea. It could be, depending on the graph they're trying to make. For this example, it's actually the amount of views that Mr. Beast has on his YouTube videos in total. It's probably impossible to guess that, but this kind of shows where Mr. Beast is in terms of view count. So he's probably like here or let's see, entertainment. Yeah, Mr. Beast thing is right here, this little dot right here. But it's crazy to see how many channels have more overall views than Mr. Beast. Everything above this blue line has more views on their videos than Mr. Beast overall. It's pretty cool to see how many channels might be thriving that we may not know about and how much there is to this data, how much stuff we can interpret and conclude. So we've gone through, the general real plot, and now let's look at another plot, which is the display plot. So in order to use it, all you have to do is display, and here we have started, right? And started is essentially the column that correlates to when the channel has started. And we have a little to do here, and you can do this on your own time, honestly, because it's not really relevant to the rest of the code for this presentation. But if you want to change the axis, you can. But I'll just run this really quickly. And we'll see that it provides a histogram that shows the count and the year, very similar to what David has done. And using its own, Seaborn aesthetic, it shows the same thing. And if you guys want to make it so that the data only shows, within this range of X values, you guys should go try it out. It's a pretty good tool to learn how to adjust data and adjust axes in order to make sure your data is succinct and really easily interpretable by people that might not be exactly knowledgeable within data science and stats. So we can also plot the kernel density estimate, which is really important because sometimes you want to see the density and not just the count. And you can do that by using the same keyword as before, kind, and then specifying it to be KDE, which is the kernel density estimate. So if we run this, we can see that now instead of having, is it buckets?
Buckets.
Buckets, right? Now instead of having buckets, it's a more smoother graph, which kind of shows that with like during 2020, during 2010, around that area is when the most number of channels that right now have the most number of subscribers. That's when they started making YouTube videos. You can see there's like a huge uptick from 2005 when YouTube probably first started around here to 2010, and then now as newer channels come, it's obvious that they may not be in the top 1,000 YouTube channels. So this gives us a smoother graph that shows the density of channels over a period of time. But let's say we want to compare, the buckets of the histogram with the more smoother graph. We can do that by just saying the KDE equals true and not specifying the kind. And we essentially get both graphs layered on top of each other. So you're able to say, hey, we have these specific, depending on the number of buckets you want to have within your data, here is the averages using the KDE or the density. And you also have this histogram. So you can see that maybe a client would like to see this outlier and see what channels are these specifically that blew up in 2006. Was there a category that you can edit them all? And that is something that the KDE will not show, but the KDE is still really important to show the overall trend of this graph. Everybody good so far? I'll take that as a yes. Cool. Yeah, we can also customize the plot to include more details or changes. So, sorry, instead of buckets, sorry, I meant bins. The number of bins as in the blocks in the histogram. And Seaborn allows you to stylize your graphs and make it do some really cool stuff. So here we have dark background. I just added dark background, but you can do stuff like 538, which is named after the sports stats company that makes a lot of news articles about sports stats. And I specify the number of bins, the color, and then make KDE true. And then we just added a title to the graph, font size, color. And then if we run this, we can see, boom, it's completely changed. Now, if your presentation, let's say, is in like black or white, you can use this to, more accurately show your data. So let's say I do the dark background. I do 538. Boom. And now, even though it's hard to see because it's all white, the font, let me actually change the font. Okay, so it shows the font. I mean, this stuff is still hard to see, but this is the typical graph structure and aesthetic that 538 uses. Oops. But yeah, pretty cool stuff that you can do with Seaborn. It's a very customizable library that you can use to really make your data sets pop, to really show your graphs. And finally, we'll be going over another graph that Seaborn is really useful for. This data set is not the best, particularly for showing this type of graph, but especially regarding timing or a data set where you're looking over a series of time and you're seeing the changes with that. A heat map is really useful. Does anybody know what a heat map is, or does anybody not know what a heat map is? Oh, everybody knows what a heat map is? Cool. If you guys don't know, a heat map is just an average graph that shows the correlation between two variables, but it uses colors to show the intensity of how much a a correlation is there between two variables. So if we run this, here I have rank, video count, and video views. So to create a heat map, all you have to do is make sure you specify which values you are looking at, and you can use a pivot keyword to show which two categories you want as your XY axis, and then which one you want to show the intensity of. So typically a heat map will have all these values as different colors, and of course it's hard to see again on the projector. But this is orange, this is also orange, this is very light, and this is dark. And what that essentially is saying is, with this little bar here being the intensity from number of views to the most amount of views, from 0 views to the most amount of views, we can see that the number one channel in terms of rank has, around I would say billion, 200 billion,
200 billion.
200 billion views overall, which is, insane. And here we have video count. So for around 8,000 or 18,000 videos, they have 2 billion views, which is all like Indian songs. But like, yeah. And rank number 2, we can see YouTube movies has 0 views and 0 videos, but they're somehow the second most subscribed channel, which is pretty crazy. Here we have, I think, Coco Melon or something. Let's check.
Cocoa and education.
The Coco Education. Yeah, Coco Melon and Set India and Mr. Beast, right?
Yeah.
So we can see here Coco Melon has only around 700 views or 800 videos, but it has a crazy amount of views over, 1.5, 1.75 billion views. Or sorry, 175 billion views. And we can keep going down. Mr. Beast is right here. And yeah, that's basically it. These are some of the visualizations you can use for you can use within Seaborn. It's a really great tool for you to really up the ante on your data analysis and show some really cool visualizations. And yeah, that's about it.
Yeah, so that's pretty much Seaborn. So yeah, so next part would definitely be dashboards. However, we're kind of pretty short on time. It's pretty much like 6 p.m. So
Yeah. So unfortunately, we're gonna have to not do the blue part.
yeah, unfortunately not.
But
Yeah.
that depends on our schedule.
Yeah, we might do the dashboard part next week. Might just delay it to that time. But yeah. Other than that, that's pretty much it for today. If you guys have any questions, feel free to stay over and talk to us. But other than that, yeah, that's pretty much it. So yeah,
Yeah,
thank you for coming, guys. Thank you.